Thank you, André. Yeah, it's nice to be here in Hasselt, which is our sister university in Belgium, Limburg. So we are combined in a transnational university, Limburg. But I want to talk today about a European project that has also been finished this year in March. I created one slide that gives an overview over the project, and then I will go into detail to the pedagogical models that we developed. So the project is a project in the 7th framework, one of the last projects in the 7th framework program of the European Union, and one of the first on learning analytics. So we had pioneering tasks in this. The partners, we had 11 different partners for the project, partly in the user areas and a part in developing partners. And the idea, the main task that we wanted to solve was how to improve the experience in workplace-based learning. And workplace-based learning is an area of learning in which people, for instance, a doctor, before he's going to be a real doctor, he has to have some insight in hospital training. A teacher that wants to become a teacher has to go to the classroom and do a part of teaching there. And the third domain that we looked at, the veterinary doctor, also has to do some work in practice before he can be a real doctor. Well, this is workplace-based learning, and typically this is very unstructured learning. There are no courses, there are no examinations, there are no fixed time slots. You have to learn in your own time. And to support workplace-based learning, the last years, e-portfolios have been introduced, and these e-portfolios contain assessments at the workplace. So during your learning, your supervisor can have a look at you and make an assessment of the activity you just did, and this assessment can be stored in your portfolio. So after a few months or years, your portfolio is going to be very full with a lot of small assessments by all kinds of peers and supervisors and maybe even patients that have said something about your evaluation. Well, this is a very nice tool, but the information is getting overwhelming. So you get too much information for a teacher or for a student or for a supervisor to see what's really happening. So that's why this project tried to add something to the portfolio, a type of learning analytics to the e-portfolios. And we decided to use student models to do that. So the student models certain pedagogical processes going on during the learning. The student model takes information from the portfolio and translates this information to some diagnostic conclusions. And these conclusions then are fed back to the student in the form of small messages about, okay, maybe you should watch about this aspect or another aspect. And we also give feedback in the form of graphs, a small dashboard. And this is inside the e-portfolio system. Yes? No, in this project only from the e-portfolio. But the e-portfolio can contain material from a lot of different sources. So this is basically the large project we did, and I want to talk today about these student models. So what is a student model? A student model is a representation of the variables and their relations that play a role in the workplace-based learner. For instance, his performance level, the motivation, the consistency. And we use Bayesian networks to represent student models. And Bayesian networks are grounded in probability theory, so they are mathematically sound, and they allow to predict the inner state of a student in a very uncertain environment. And we use a special type of Bayesian network. It's called the multi-entity Bayesian network, and that makes it possible to take the particular context of the student into account. Because all work-based learning is so flexible that every situation is different. So you cannot take a fixed model. Okay. Well, our models take as an input the content of the e-portfolio. For instance, assessment scores in the portfolio, or findings generated from the portfolio. So we have a generator that looks at the content and tries to extract higher level information. And the output of the model are probability tables. For instance, given the observed portfolio, it can say, well, the probability that the motivation is high is 70%, and the probability that the motivation is low is 30%. This is the output of the type of output the models give. And this output is then used to generate an appropriate message. For instance, if the motivation is low, has a high probability, then you could send a message, please contact your mentor to talk about your study progress. That's what the general idea is. Okay, in the Watchme project, we developed two different models. A performance model that was developed by the University of Reading in England, and the pedagogical model, and this was developed by Maastricht University. The performance model really looks at the level of the assessments and try to predict a level of performance for the student. And in the pedagogical model, we are more looking at behavioral and more metacognitive aspects of learning. Okay, at the start of the project, we didn't have any idea on what to put in the models. So we had to make a design of the model, and we had to decide what to put in it. Well, we interviewed a lot of, about 12 scholars that are really doing research in workplace-based learning, and asked them what is important in workplace-based learning, what aspects are important. And we created a mind map of all concepts that are important. Some things like competence, motivation, and all kinds of major and minor concepts. Well, this is too much to put in a pedagogical model, at least in the duration of the 3 years that we had in the project. So that's why we picked 5 teams out of these models, and on the basis of feasibility. So do we have data about these elements, or can we extract data for these elements? And the 5 teams that we selected were feedback-seeking behavior. That means in a workplace, you don't get your feedback unless you ask for it. So you have to show behavior that is profitable, so you have to ask feedback enough and on the right aspects. Frustration alert, and that we've seen that before. This is a drop in engagement. So less engagement, then maybe something's wrong with the student. We look at completeness of information. So does the portfolio contain enough information for the supervisor to make a decision? The portfolio consistency. So is there, and that was a rather difficult concept, but we tried to make a definition for that. And the need for feedback. So students in different levels of their education need different types of feedback. But we did not implement that in the end. Okay, we discussed those themes again with the experts for further refinement. Okay, the next step was building the model. So this is a graph that shows one piece of the student model as represented by a multi-entity belief network. It's a little bit technical, so I'm not going to go in lots of details. But what you see are in the areas in the boxes are the variables that are important in the model. Like, for instance, has the score dropped of a student? Or is the student frustrated, yes or no? Or did the number of assessments change lately? Some of these variables are input variables that we can extract from the portfolio, and some of them are output. For instance, the is frustrated is the output of this part, because that's what this part is trying to find. And between the variables, you see arrows, and these arrows represent the relation between those variables, and this relation is probabilistic. It means that for every value of an input node and for every value of an output node, there is a probability in a table. And these tables can be quite extensive, depending on the number of different states of each and the number of incoming arrows. But these tables represent the probabilistic knowledge about these variables. And these tables come from literature, for instance, or from insight of the experts. So they are more or less subjective probabilities. In a later stage, when you have a lot of data, you can try to replace them by probabilities from data, but you start with subjective probabilities that indicate the state of our knowledge on these variables. Okay. In multi-entity belief networks, the nice thing is that you can make these pieces of model independently. And then later on, when you have a concrete student, a fixed student, the model will pick the pieces of model it needs and makes a copy of the model, as many as it needs, and then generates one big model out of it. And this is the student-specific model that is used in the system. Okay, when the model is run, that means when the data is input into the model, all these variables will get their internal states filled with the actual probability of that state. For instance, we see here that we have two nodes that tell something about the feedback strategy of the student, and we see that it has a state for T0 or T2 or T3. Well, that means that our model can deal with different time steps. For every time step, it makes a copy of the model and connects them together to make one big model. And in the end, we are interested in the lowest state in which the student is frustrated or not, and says, okay, at T0, the student was not very frustrated, but at T2, it appeared to be more frustrated. Okay. Well, a big question was how to get information into the student model. So how to translate the portfolio into inputs for the model. Well, we used a number of methods to do that, and one of the methods we used at different places was to use sliding window technology. For instance, we were interested in whether the score of a student dropped on assessments in general. So this is just an example. We have the time and we have the different assessments with the different assessment scores. And as you see, there's a clear point in time where the scores drop. So this is an interesting point in time. Well, how to detect them? Well, you can use two sliding windows and then use a t-test to see the difference between the windows. And when the t-test says, okay, there's a significant difference, then you will have a drop. This is a very easy way to do that. There are more extensive ways to do that. And we did this similar types of functions for all the input nodes. So we had a function for the score drop, for the usage change, for where is the most variation in which subject, is the usage of the portfolio consistent over subjects or over time, and is the score consistent over subjects or over time. For all of these things, we made this kind of small functions. And what you get then is, I'm going a little bit fast, but that's not a problem. What you get then is this figure in which all the findings of one student are presented. On the y-axis, you see all the input, all the findings named. For instance, did you get on the top? Oh, is this a pointer maybe? Here. No matter, doesn't matter. Yeah, I can use the mouse pointer. Yeah. So on top, we, for instance, have the finding whether. Huh? Oh, this one. Okay. Yeah. Okay. Yeah. Here, we have, for instance, whether the student receives feedback from a supervisor, whether the student gets feedback from peers, and each dot is a moment in the portfolio, and the moment is in weeks, is a week in the portfolio that we see feedback from a staff. And here is a point time we see feedback from students. And the higher the point, the more feedback. And we make discrete steps, so a lot of feedback, little feedback, or no feedback. Here we have variable whether we could detect a drop in score. We'll see that there are not many points because in many weeks we could not detect significant drop in score. But in these weeks we could detect a significant drop. And this is a small drop, and here we have a large drop. And same for consistency of scores. So here we could say, well, there's high consistency and low consistency. Change in usage, well, here we have a small change in usage. And then the portfolio was organized in different domains, different competencies. And for each of the domains, we said whether is this competency a hotspot, in the meaning that we see a lot of variation in that competency related, if you compare to other competencies. We can see whether you have different feedback from different persons or different types of feedback, and whether there is change in usage in this competency. So a lot of observations on the portfolio, and this was input for the student model. So this was extracted from the portfolio, but this already tells a story about the student. So we see a gap here, so no observations here. So maybe there was something special with the student. Here we see this drop in score, so here's something happening. Okay, when we put this into the model, then the model will generate this as output. Oh. Okay, like that then. Okay, doesn't matter. We have two tables. On the horizontal axis is the time, and the vertical is the probability, and this is the output of the student model nodes. And we have different nodes, so feedback seeking strategy, frustration level, and inconsistency in portfolio. And one interesting one is the green line, the frustration level. So it's not the frustration level, but it's the probability that the frustration level is high in correct times. And we'll see here that this green line has a peak here. Okay, and that's correlated. And we see another big peak here, but this peak is, this peak is correlated with this gap, and the other peak is correlated with what's happening here. So I can explain a little bit what the probabilities do. And these probabilities are then used to send out messages to the student. So if we have a certain threshold, for instance, 0.5, then here a message will be sent, and here a message will be sent. That's how the model works. This is all theory. Well, of course, the system was evaluated. That's why we had all these using partners in the project. So we had about 318 students using the system, the portfolio system, with the student models. in 8 different contexts, so medicine, veterinary medicine, and teacher training. And well, we see that it's possible to catch metacognitive processes using a probabilistic model, and use ePortfolio as an input. So we've shown that the concept is working, but the design of the interaction appears to be crucial. So what messages are you going to send to the student at what time? Well, and one aspect that we did not expect at the start is that diagnosis of these metacognitive processes takes a lot of time. And you can see it on the scale in this graph. We are talking about weeks. So this is a period of about 3 years, almost 3 years. And in the project we had about 2 months time to do evaluation of the tools. So the processes were too slow for the evaluation period to come up. And that means that students, that very little signals were found and were communicated, so students could not react on these signals as much as we would liked. But nevertheless, we developed the architecture, we developed the systems, we developed the visualizations, and they all worked. So this can be applied in many other domains, and maybe in domains in which processes are a little bit faster, like in courses. And if you would like to try out the system, I'm giving workshops on the subject now and then, and the next one will be at the NVMO conference, Nederlandse Vereniging voor Medisch Onderwijs conference in Noordwijkerhout, and one of the pre-conferences will be on how to build a student model using the technology that we used. Okay, so this is what I wanted to tell, and maybe we have time for some questions. Yeah. Yes, I understand that. But we would not give the graphs to the teacher. So the idea is that that only the messages are sent to the teacher and the student. So, but you could do that. We didn't design that in our system, but. If you look at this graph, and I showed this graph to teachers or to supervisors in the area, so with the idea, well, you know the student. Can you explain this graph? And says, oh yes, yeah, no, there's no big problem, because this area, this was a female student, and she was on pregnancy leave here, so that's why there were no entries in the portfolio, and that's why all kinds of signals went wrong. This was a difficult period in the portfolio, so this was also explainable. So yes, of course, you have to for any type of dashboard you have to train the users of the dashboard. I'm not so worried so much about the dashboard. Yeah. 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 Then what action do you take as a teacher? Yeah. 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 No, there's no single answer for that. No. In a workplace-based setting, any problem is always a complex problem that you. Yeah. If you have, let's say, ideas on which factors you might have taken, which could have been more actionable. Yeah, yeah. Yes, that's indeed a good question. Yeah, one thing is that appeared to be very important is we looked mainly at scores, but portfolio contains a lot of narrative information, and this narrative information is much more important than the scorings. And this was planned in the project to look at narratives and to use text mining, etc. But I think there's more information in the text and the messages and than there is in the scores. And so that would be another factor that we would have to look at. Yeah.
You have two, it's workplace education.
Yeah.
Two types of workplace, teacher education and medical education.
And veterinary medicine. Yeah, yeah.
I was wondering whether for creating this student model you have to get data into your total attestation theoretically.
No.
I can imagine that for the medical studies you get more data than from teacher education and a number
Yeah.
of people. Is that causing
Yeah.
problems
Yeah.
or
Yeah.
challenges?
Yeah, that was causing challenges because medical students, they spend in the internship, they spend maybe 2 or 3 years there, and the teacher has a period of 6 weeks in class or 1 month or 2 months in class, with only, and also the number of assessments in medicine was much higher than the number of assessments in teacher training. So, so this causes problems in did you find little signal in teachers?
The connecting question would be that for your metacognitive process, it
Mhm.
might be easier to compare, okay, what works for adults, maybe for the workplace,
Mhm.
and for medical education is can be translated to what you do for the teacher education.
Yeah.
The performance level, I can imagine that it's a bit more difficult.
Yeah, well, one big part of the project was to define these performance indicators. So there were a series of publications about, well, what is important in this area, what's important in that area. Yeah. So that's, I think, one of the things that went very well in the project. But given that you want to do this, it could also be to say, okay, maybe we have to redesign Teacher Academy and have them make more assessments during that work and not only at the end or halfway. So there's also a possibility to say, okay, maybe if you want to have useful feedback, you need to have a higher frequency. Okay.